Okay, so you set over some really interesting stuff for us to dive into today, all about how blockchain technology can really up the ante for organizations in terms of efficiency and security.
Yeah.
We've got this book all about Avalanche,
Right.
real-world examples of where it's actually being used, and then this analysis from the Government Accountability Office, the GAO,
Hmm.
that kind of digs into some of the issues with traditional blockchains.
Right.
So our goal for this deep dive is to really get to the heart of what Avalanche is all about,
Yeah.
especially how its dual-layered security approach works, and how it actually makes sure that all those transactions are legit.
Absolutely. And I think it's really time to move beyond, that kind of common idea that blockchain equals cryptocurrency.
Yeah.
What's so fascinating about Avalanche is it's really emerging as this, distinct solution, specifically engineered for like really robust operations, both in business and government.
Yeah.
And a key part of that we're going to unpack is its custom-built layer one architecture.
Okay. So before we jump into all that, can we just lay some groundwork here?
Sure.
Just really quickly, what is blockchain? How is it different from those traditional databases that most organizations are using?
Okay, so think of it this way. Traditional databases, they usually keep all their information in one central place,
Okay.
which can be a bit of a vulnerability.
Mm-hmm.
Blockchain completely changes that because it decentralizes everything.
Okay.
So instead of one central hub for the data, it's actually spread across a whole network of computers, which are often called nodes.
Okay.
And it's this distribution that gives blockchain its core strengths, things like immutability, transparency, and security. So once a piece of information is recorded on a blockchain, it becomes incredibly difficult to change or delete. Without a consensus across the entire network,
Mhm.
the history of these records is often viewable by participants,
Okay.
which promotes accountability. And then the data itself is protected through advanced cryptography, so it's super secure against unauthorized access.
So it's almost like
So,
instead of having one potentially vulnerable safe,
okay.
we got all those same records mirrored across lots and lots of highly secure locations.
Yeah, exactly.
Now, our sources also talk about single chain versus multi-chain systems, and they position Avalanche as a multi-chain system.
Yeah.
So what's that core difference that we need to understand?
Okay, so single chain networks, they're like the earliest forms of blockchain, and they handle all transactions on one main blockchain.
Okay.
And while that was, revolutionary at the time, it can lead to bottlenecks when the volume of transactions gets really high.
Mm-hmm.
So multi-chain networks, on the other hand, are designed to support multiple independent blockchains operating in parallel. In the Avalanche ecosystem, these are often referred to as layer ones or L1s.
Okay.
And the key point here is that while these L1s function independently, they can also communicate with each other, which creates this really flexible and scalable system. This is a big advantage, particularly for large organizations that have, diverse and potentially high volume needs.
So our mission for this deep dive is to really understand how Avalanche's this unique setup, particularly the layer one architecture, its dual layer security, and its validation process, meets that need for both efficient and secure operations. So where should we start?
I think a great place to start is with Avalanche's layer one architecture.
Great.
And what makes it so remarkable, what I find so fascinating is the sheer level of customization and independence it offers. It's almost as if Avalanche provides the toolkit for anyone to build their own blockchain,
Okay.
tailored specifically to their own unique requirements. You can imagine it like having these highly adaptable building blocks for blockchains. And this is where the potential for, high scalability comes in, because you can have loads of these independent chains running simultaneously and importantly interacting with one another. And our sources really emphasize just how quickly these L1s can be deployed. We're talking a time frame of hours or days compared to, the potentially much longer timelines associated with traditional system deployments.
Numbers or days versus potentially years for traditional systems. That's a huge difference in deployment speed.
It is.
And you mentioned this high degree of customization. What kind of choices do organizations actually have when setting up these individual L1s?
Well, the flexibility is pretty remarkable. So an organization can decide if their L1 should be public. Private permissioned, meaning that access is restricted to authorized participants only, or fully decentralized. And this ability to fine-tune each chain is absolutely vital for meeting, specific regulatory compliance obligations and adapting to different legal and jurisdictional requirements. You could even imagine scenarios within large entities, like government agencies or corporations, where different departments actually operate their own dedicated chains.
Okay, so like department-specific chains.
Exactly.
So for example,
Right.
a major government agency could have one L1 specifically for its finance operations,
Right.
another completely separate one for its legal department,
Mm.
and then maybe a third for its core operational functions. What would be the benefits of a system like that? So segmented yet interconnected.
So, by having these interconnected yet independent chains, you unlock several key advantages.
Okay.
The material highlights real-time auditing as one, because every transaction is recorded immutably on the respective blockchain. Different departments or oversight bodies can have immediate and transparent access to the relevant activity.
Mhm.
You also see the potential for much faster execution of services, more streamlined record-keeping processes, and highly efficient payment processing,
Okay.
all optimized for the specific workflows and needs of that particular department.
That makes a lot of sense. In terms of internal organization and efficiency, so we've got this flexible layer one structure. Now, the book you shared really emphasizes the Avalanche's dual layer security. Can you break that down for us?
Sure.
What does that actually entail, and why is it considered such a strength?
Well, this is a really fundamental aspect of Avalanche's design. The first layer of security comes from the inherently distributed nature of the network itself. So as the material explains, each department or agency that operates its own L1 can also run nodes, which are the computers that validate transactions and maintain the integrity of the blockchain, not just for their own L1, but potentially for other departmental L1s as well.
Okay.
So this creates a really broad and geographically dispersed network of validators, making it exponentially more difficult for any single point of attack to compromise the entire system. It's a classic case of security through distribution and redundancy.
So the more independent entities
Yeah.
actively participating in validating the network, the more resilient and secure it becomes
Right.
against those kinds of attacks. That sounds like a really strong initial defense. What about a second layer of security?
So the second and equally critical layer is provided by the Avalanche main blockchain itself. This main chain acts as a settlement layer, sometimes called the X chain within the Avalanche ecosystem, and it extends the security umbrella over all the individual L1s connected to it. So when transactions on a specific L1 reach finality, meaning they are confirmed and irreversible, only the record of that transaction, specifically the cryptographic hash, is transmitted to this main settlement layer. The underlying sensitive data contained within the transaction remains on the originating L1.
Ah, okay. So it's like a highly secure notary service.
Yeah.
The main chain provides an indisputable record that a transaction occurred and that it was verified, but it doesn't need access to the private details of what that transaction actually involved.
Right.
That sounds like it would be so important for maintaining data confidentiality and sovereignty.
Exactly, and this design inherently protects data sovereignty. So each department or entity retains complete control over its sensitive information on its own dedicated L1. What's particularly noteworthy is how this architecture directly addresses some of the key security vulnerabilities that the GAO identified in its analysis of more traditional blockchains, especially concerns around the potential for data tampering and the risk of cyber attacks. So
Yeah.
by having this widely distributed network of validator nodes, all ultimately anchored to the security of the main settlement layer, Avalanche really significantly reduces these risks.
Okay, so we have this multi-layered system with independent L1s that benefit from the security of this main chain.
Right.
Now let's talk about how validation of transactions actually happens within this framework,
Sure.
especially given that we have these separate L1s operating.
So this is where the interconnectedness of the system becomes really apparent. So while each L1 operates autonomously and can even have its own specific rules for processing transactions, their fundamental security is reinforced by the main settlement layer. So the initial validation of transactions on an L1 is handled by the nodes operating on that particular chain, according to its specific configuration and rules. However, the final confirmation and security of those transactions are ultimately tied back to the robust security and consensus mechanisms of the core Avalanche network.
So even if a specific department has its own set of validators for its particular L1,
Right.
the ultimate trustworthiness and security of those transactions are enhanced by the strength and reliability of that broader Avalanche network.
Exactly, the distributed validator nodes, which could potentially span across various government departments or different business units within a corporation, all contribute to the overall security and the validation process across the entire Avalanche ecosystem. The sources highlight a crucial point here. Even in the unlikely event that a single isolated L1 were to be compromised, which would be extremely difficult given its own distributed nature, the entire system would remain secure. because of this dual-layer security model. So it provides a significant degree of isolation and resilience.
Okay, this all sounds incredibly promising from like a theoretical standpoint.
Mm-hmm.
But what about how this translates into real-world applications? You've shared some sources with me. That includes some specific examples of where Avalanche is actually being used in practice. So let's talk about those.
Yeah.
The first one that really stands out to me is the California DMV.
Okay.
What's happening there?
This is a really compelling example of large-scale adoption within government. So California Department of Motor Vehicles has successfully digitized a staggering 42 million vehicle titles onto a permissioned Avalanche L1.
Oh.
And the impact has been pretty transformative. They've reported a dramatic reduction in the time it takes to transfer a vehicle title, from what used to take weeks down to just minutes. The integration of immutable smart contracts enhances the security of these records. And the tamper-proof nature of the blockchain significantly reduces the potential for fraud. It's also important to note the sheer scale of this deployment. Managing 42 million records is massive. And the fact that the system is designed to support streamlined, mobile, accessible processes for citizens.
So weeks to minutes.
Yeah.
That's not just like an incremental improvement. That's a complete shift in efficiency and a so much better experience for the public.
It is.
Another really interesting example is the partnership between FEMA and Deloitte.
Okay.
What's the focus of that collaboration?
So this initiative is centered around improving disaster recovery efforts. So the Federal Emergency Management Agency, FEMA, and Deloitte have together deployed this blockchain-based platform on Avalanche. And it's specifically designed to streamline that often complex and time-sensitive process of disaster reimbursement applications. The key advantages here are a more secure and transparent way of handling these critical financial transactions. Avalanche's rapid consensus mechanism and the ability to customize L1s for specific regulatory requirements are really crucial in providing the necessary scalability and control in these high-pressure situations.
Yeah. Imagine the difference it can make for individuals and communities trying to rebuild after a devastating event when the reimbursement process is that much faster and more transparent.
Absolutely. Reducing bureaucratic delays in those critical situations can have a profound and immediate impact on people's lives.
And the sources also mentioned adoption by private sector firms, including Lemonade Insurance and even Deloitte themselves. Yeah. So what's driving that adoption within the corporate world?
Well, the reasons are pretty compelling and multifaceted. The material points to significant gains in speed of operations, a radical reduction in overall operational costs, the inherent scalability of the platform to handle growing business demands, and the crucial ability to securely integrate with existing legacy IT systems. For companies like Lemonade Insurance, leveraging smart contracts on Avalanche L1s is enhancing their risk management capabilities and significantly streamlining their claims processing workflows, leading to greater efficiency and potentially lower costs for their customers. And Deloitte's own adoption of the platform really underscores its versatility and its suitability for enterprise-grade applications that demand both high performance and robust security protocols.
So we're seeing these tangible and significant benefits across such a diverse range of applications, both in the public and private sectors. Now let's go back to that GAO report for a second. It highlighted some limitations and challenges associated with those traditional blockchain implementations. How does Avalanche, with its unique architecture, specifically address those concerns and potentially offer superior efficiency, particularly within government?
Well, this is where Avalanche's architectural choices really stand out when we compare it to the challenges that the GAO has identified. So let's think about some of those limitations. The GAO report often mentions issues around interoperability, the difficulty of different blockchain networks, communicating seamlessly with each other. Avalanche's custom-built L1 architecture, which includes its interchain messaging or ICM capabilities, directly tackles this. So it allows these department-specific or application-specific chains to communicate securely and efficiently, effectively overcoming data silos. What's particularly innovative is the potential for an L1 to even leverage infrastructure from other blockchain networks. Creating this truly interconnected and flexible ecosystem. So it's not just about internal communication within the Avalanche network.
It's that potential for interaction. And data exchange with other blockchain systems as well.
Exactly.
Which could really help break down some of those data silos that the GAO is concerned about. Now, what about security and data integrity? The GAO raised concerns about the potential for inaccurate data entry and vulnerabilities. That could compromise data privacy on traditional blockchains.
So Avalanche's dual-layer security model, which we discussed in detail, is a direct response to these concerns. That distributed network of validator nodes, which can be operated by different entities within an organization or even across organizations, really minimizes the risk of centralized attacks and data tampering. Furthermore, that fundamental design principle of data privacy by design, where the raw sensitive data is encrypted and remains on the specific L1, with only the secure transaction record being committed to the settlement layer, directly addresses those privacy vulnerabilities. This approach ensures both the accuracy and confidentiality of data, in a way that earlier blockchain designs sometimes struggled with.
Now, the GAO also brought up questions about operational efficiency and the potential for high costs associated with running and maintaining blockchain applications, noting that some implementations can be pretty resource intensive.
Yeah.
Well, how does Avalanche compare in terms of operational efficiency and cost effectiveness?
So the material really emphasizes Avalanche's rapid and flexible deployment, the ability to get new systems up and running in a matter of days or weeks, rather than the months or even years, often associated with traditional IT projects. This rapid deployment capability immediately reduces upfront costs and minimizes disruption. Additionally, the near-instant transaction finality and incredibly low transaction fees, in some cases fractions of a single cent, significantly lower ongoing operational costs, and the proven reliability of the Avalanche network, which has maintained near-continuous operation with virtually no downtime, directly addresses the GAO's concerns about long-term maintenance and resilience. That example from Elon Musk, highlighting the inefficiencies of manual record-keeping, really underscores the potential for substantial cost savings through the automation that a platform like Avalanche enables.
Yeah, absolutely. That example really highlights that contrast between those outdated manual processes and the potential for these modern, efficient blockchain solutions. Now, finally, the GAO report also pointed to regulatory and customization considerations as potential hurdles for widespread blockchain adoption, especially in the highly regulated public sector.
So this is yet another area where Avalanche's unique L1 architecture provides a real advantage. Those inherent dynamic customization capabilities allow each individual L1 to be precisely tailored to meet the specific regulatory requirements and operational needs of different jurisdictions and government departments. This means government bodies can maintain a high degree of control over their own infrastructure and ensure compliance with relevant regulatory standards within their own dedicated ecosystem, rather than being constrained by a one-size-fits-all blockchain solution. The integrated nature of the Avalanche ecosystem also extends this potential for regulatory compliance beyond just government departments, to include enterprise partners operating on their own L1s, creating a broader network of accountability and trust.
It really sounds like Avalanche has been designed with a real awareness of those earlier criticisms and limitations of blockchain, especially in the context of organizational and governmental use. And the book also touches on the concept of integrating policies and contracts directly onto the blockchain. So how does that work within Avalanche's architecture?
Well, the integration of policies and contracts as fully digital and automated smart contracts on Avalanche L1s really takes advantage of that inherent cryptographic security of the blockchain. Smart contracts are essentially self-executing agreements, where the terms are directly written into code. And these are secured by cryptographic keys, so only authorized parties can trigger their execution. This allows for organizational policies to be encoded as smart contracts, automating the tracking of their implementation and ensuring consistent enforcement. Updates and modifications to these policies can also be applied seamlessly across the network. Once they're approved through the defined governance mechanisms, the material even suggests the possibility of having dedicated L1s, specifically for managing and enforcing policies, and separate L1s for housing and executing contracts and agreements, which further enhances organizational clarity and security.
Wow, that level of automation and inherent security for such crucial documents like policies and contracts sounds incredibly valuable for any large organization. Okay, so to really bring it all together, it seems like Avalanche's innovative Layer 1 architecture, coupled with its robust dual-layer security model and its efficient validation processes, represents a really significant evolution beyond those earlier blockchain implementations. It directly addresses many of the key concerns surrounding scalability security, cost-effectiveness, and regulatory compliance that were highlighted in that GAO report. And the real-world examples that we've discussed today offer compelling evidence of its benefits across a variety of sectors.
Precisely, and what's really significant is how Avalanche has been specifically architected to meet the demanding operational requirements of both government entities and large-scale enterprises, effectively expanding the utility of blockchain technology far beyond that initial association with cryptocurrencies. The ability to create these highly customized and interconnected chains, all while benefiting from the underlying security and interoperability of the main Avalanche network, seems to unlock a vast array of new possibilities. For secure and efficient operations.
Okay, so as we wrap up this deep dive, here's a final thought for you to consider. Given Avalanche's unique capabilities in creating these highly tailored L1s, with such a strong emphasis on dual-layer security, what novel possibilities might this unlock for establishing secure and efficient collaborations? Think not just within the boundaries of single organizations, but also across different sectors, perhaps government agencies collaborating seamlessly with private companies, and even across different legal jurisdictions on a global scale. It really prompts you to think about the broader implications that extend beyond the specific examples we've explored today. Thanks for joining us
It's been a pleasure.
for this deep dive.